Hey guys, Mr. B here, and in this video we're going to be going over chapter 12.2 and looking at the practice problems. So let's begin with number 1. It says true or false, according to Newton's first law of motion, an object's state of motion does not change as long as the net force acting on it is 0. So this is true. This is exactly what Newton's first law says. Basically it says that an object's motion, whether it's moving or not moving, or its state of motion, is going to remain the same as long as there's no net force acting on it or the net force is equal to 0. So this is true. Number 2, what is inertia? So this is directly from the slides, but inertia is usually going to be the tendency of an object to resist a change in its motion. So if you want to put it in our own words, we could say it is the tendency of an object to continue doing whatever it was doing. So if it's moving, it will continue to want to keep moving in the same direction at the same speed. If it's not moving, it will continue to want to sit still and not move. Okay, we're going to use the definition from the slides though. So we'll say inertia is the tendency of an object to resist a change in its motion. All right, number 3, true or false. The law of inertia states that an object in motion will eventually slow down and come to a complete stop if it travels far enough in the same direction. This, although of course this is a true thing, right? Like objects will eventually come to stop if they go far enough. That's not because of the law of inertia. That's because of friction. If you had an object in outer space and you were to throw it, it would go forever. Because its inertia would just keep it traveling. So this actually is a false statement here. Okay, this is false. The law of inertia basically says an object will just keep on doing whatever it's doing as long as there's no forces acting on it. It will not eventually slow down. The only reason things slow down on Earth is because there's friction, and friction slows things down. So if you could go somewhere where there was no friction, they would go forever. Okay, number 4, according to Newton's second law of motion, an acceleration of an object depends upon the blank of the object and the blank acting on it. So again, this is from the slides, but basically Newton's second law says that the acceleration object depends upon the mass of the object and the net force that is acting on that object. Okay, so mass and net force. Number 5, it says match each term with this description. So a measure of the inertia of an object, this is actually going to be A, which is mass. The mass of an object is essentially a measure of how much inertia it has. So the more mass of an object, the more inertia it has, the more difficult it is to get it to change its motion, whatever it's doing. Number 6, net force divided by mass. That is Newton's second law, so that is going to be equal to acceleration. Okay, so acceleration is net force divided by mass. And then lastly, number 7, this causes an object's velocity to change, and that is net force. Okay, so if you put a net force on an object, that will cause the object to accelerate. Whether it slows down, it speeds up, it changes direction, it's still an acceleration. Okay, last questions here. Number 8, what is weight? So weight and mass, of course, were two words that were in this chapter section, and they're both words that we use interchangeably a lot in our everyday language, but there's a difference between the two, okay? Remember that weight is a measure of how much gravitational force is pulling you to the ground. Your mass is a measure of how much material is in your body, okay? So as for what is weight, we can say that weight is the amount of gravitational force pulling you to the earth. Okay, so your weight is how much gravity is pulling you down to the earth. Number 9, write the formula used to calculate the weight of an object. All right, so this is in the slides. If you go back, it's given right here. Weight is equal to mass times acceleration due to gravity. So we're going to write that down. So we'll say that weight is equal to mass times acceleration due to gravity. All right, last one, number 10, true or false. Because the weight formula shows that mass and weight are proportional, doubling the mass of an object will not affect its weight. All right, so what this is saying is basically the weight formula is saying that mass and weight are proportional. So that means as one goes up, the other goes up. As one goes down, the other goes down, right? So if you have more mass in your body, you weigh more. which means that if we read the other half of the statement saying doubling the mass of an object will not affect its weight, that's false, right? Since weight and mass are related, if you double the mass of an object, then you will double the weight of the object. So this is a false statement. All right, that is the last question for this section of notes. Hopefully that was helpful. But again, as always, if you have any questions, feel free to email me or chat with me in class, or just get in touch. So, all right, guys, thanks for sticking with me. I'm Mr. B. See you in the next one. Bye.